If you rapidly add 50 milliliters of 1 molar sodium hydroxide to 50 milliliters of 1 molar hydrochloric acid in a coffee cup, and the measure of temperature rises from 19 degrees Celsius to 30 degrees Celsius, calculate the change in enthalpy for the reaction. The chemical equation for this reaction is hydrochloric acid combined with sodium hydroxide produces sodium chloride and water. Enthalpy is defined as the quantity of the total heat content of a system and is denoted as capital H with units in kilojoules per mole. First, we need to define what the system and the surroundings are. The 1 molar hydrochloric acid is the system, and the water will be defined as the surroundings. Molarity is expressed in units of moles per liter. The equation we will use to solve this problem is Q equals NC delta T. We then need to determine the total volume of the surroundings. For this, we know that we have 50 milliliters of hydrochloric acid and 50 milliliters of sodium hydroxide, which will produce 100 milliliters of water. Using this total volume, we can use stoichiometry to convert the volume of water to moles of water. The density of water, which equals 1.00 grams per milliliter, is essential to this component. Using the density of water, we can convert the volume of water to grams of water. Then, in order to get moles of water, we use the molar mass of water, which is 18.01 grams per mole, to convert the grams of water to moles of water. Now that we have the moles of water produced in the reaction, we can calculate the heat absorbed by the surroundings using our equation. The molar heat capacity of water equals 75.3 joules per mole degree Celsius. Now we just have to input the values in the equation Q of water equals N of water multiplied by C of water multiplied by delta T of water. Delta T of water equals the final T subtracted by the initial T, and the initial temperature is 19 degrees Celsius and the final temperature is 30 degrees Celsius. So delta T equals 11 degrees Celsius. We already know that the sum of the heat released by a system and the heat absorbed by the surroundings will equal 0. In other words, the Q of water plus the Q of the reaction equals 0. From this, we can calculate that the Q of water equals the negative Q of the reaction, which equals negative 4,597.065 joules. Since we are solving for the change in enthalpy of hydrochloric acid, we need the number of moles of hydrochloric acid, which can be calculated by using its measured volume and known concentration. In order to find the enthalpy of the reaction, divide the amount of heat lost by the system by the moles of hydrochloric acid. So negative 4,597 joules divided by 0.05 moles of hydrochloric acid equals negative 91,940 joules per mole. To convert this to kilojoules per mole, simply move the decimal point 3 places to the left. In conclusion, the heat released by 1 mole of hydrochloric acid to the water is 91.94 kilojoules.